Welcome to America Advances.
DARPA picks 6 firms to develop experimental ship-launched drones. The Defense Advanced Research Projects Agency, DARPA, has selected 6 companies to advance an experimental lightweight drone capable of vertical takeoff and landing from a ship. The companies chosen for DARPA's Advanced Aircraft Infrastructure, Less Launch and Recovery, Ancillary program include major defense contractors and smaller aeronautics firms. The selected companies are AeroVironment, Griffin Aerospace, Karam Aircraft, Method Aeronautics, Northrop Grumman, and Lockheed Martin's Sikorsky. These firms will now continue to develop and refine their proposed ancillary designs. DARPA envisions ancillary leading to a future drone, deployable and retrievable from Navy ships without the need for large mechanical launchers or recovery equipment. These drones would be capable of carrying cargo, conducting intelligence, surveillance, and reconnaissance missions, and tracking and targeting enemies beyond a ship's line of sight, according to DARPA. These small drones need to take off and land like helicopters from ship flight decks or rough surfaces in most weather conditions, then fly missions like winged aircraft. They must also be able to carry large payloads and cover long distances when necessary. The goal of ancillary is to increase small vertical takeoff and landing uncrewed aerial system UAS capabilities by a factor of 3 over the current state-of-the-art flying today, stated DARPA Program Manager Steve Comodina. Our performers are searching for innovative ways to increase payload weight, range, and endurance of small, ship-launched UAS by means of novel configurations, propulsion, and controls, while also removing the need for special infrastructure. Comodina noted that the Navy and Marine Corps are the most likely users of this technology, though it could also benefit the Army, Air Force, Coast Guard, and U.S. Special Operations Command. In June 2023, DARPA selected 9 companies to pitch their initial ancillary concepts, before narrowing the list to 6. These firms will now enter a 10-month phase focused on reducing the risks of their designs and conducting hover testing of their proposed aircraft elements. After this phase, companies will submit proposals to move on to the next stage, which includes fabrication and flight testing. Formal flight tests of the overall design are expected to begin in early 2026, DARPA stated. Christopher Harris, the program manager for Northrop's ancillary effort, said in an interview that the company is leveraging its work on autonomous capabilities, vertical takeoff and landing, and long-endurance aircraft design for its ancillary proposal. Meeting DARPA's endurance requirements without needing launch and recovery infrastructure is challenging, Harris said on May 24th. Northrop's aircraft will be capable of carrying payloads of 60 pounds, flying a range of 100 nautical miles, and operating for up to 20 hours. Northrop's ancillary design will use 2 rotors for takeoff and landing and another rotor for forward flight, he explained. Ancillary will be able to take off and land from a ship in adverse sea conditions and operate in highly contested environments, Harris said. It could also assist with logistics by helping unload a ship and transporting cargo to shore. Northrop is incorporating its work on autonomous capabilities, vertical takeoff and landing, and long-endurance aircraft design into its ancillary proposal, Harris noted. We have a wide array of supplier awareness, our own innovative technologies, and a team uniquely capable of delivering what DARPA is asking for, he said. Sikorsky announced on Wednesday that it is conducting flight tests on its version of ancillary. The company describes its design as a rotor-blown wing, which takes off vertically like a helicopter and then transitions to horizontal forward flight. Sikorsky stated that this design will minimize drag on the wing during hovering and transitioning to forward flight, resulting in improved efficiency and endurance while cruising. Flight tests are underway to confirm that our tail-sitting rotor-blown wing UAS can launch and land vertically with high stability and cruise efficiently on the wing, said Igor Cherepinski, director of Sikorsky Innovations, the company's rapid prototyping group. Cherepinski explained that Sikorsky's ancillary version uses an articulated rotor system similar to traditional helicopter rotors and incorporates Lockheed's autonomous matrix technology in its flight controls. The aircraft currently undergoing flight tests is battery-powered, but Sikorsky plans to develop a 300-pound hybrid electric version if selected to continue in the program. This future aircraft would carry a 60-pound ISR payload, according to the company. Method Aeronautics announced it is collaborating with Sierra Nevada Corp, known for its expertise in landing systems and aircraft modification and integration, and Bechamot, a company specializing in using artificial intelligence to create aircraft flight controls. Method's design introduces a novel approach that enables efficient, robust VTOL, vertical takeoff and landing capability for Group 3 UAS, Method stated. We view this program as crucial for developing technology that will allow for broader use of VTOL UAS by U.S. forces abroad, and we are actively working to accelerate development beyond the scope of the award. Group 3 drones weigh under 1,320 pounds and can fly at speeds up to 250 knots. Statements from AeroVironment, Griffin, and Karam were not immediately available.
That's it for today's video, soldiers. I remind you that you can subscribe to stay updated with the latest military news.